Hello, good afternoon, and welcome to today's live coaching classes. Today, we are taking up the next chapter in business mathematics, logical reasoning, and statistics. And the chapter we are going to take up is very interesting, and the chapter is sets. This is basically the first part of two consecutive chapters, one which we are doing today, and the other one which we shall be doing on the next day, and that will be on relations and functions. This is the formative chapter, after which you will be proceeding to the next chapter, which is on the calculus part, differential calculus and integral calculus. So here we go, and we start with our discussion today. The agenda for today's discussion and coverage will be like this. First, we shall understand set theory, an introduction to set theory. And this is a very interesting chapter because we will also learn about the pictorial way of showing relationship between numbers, and that is called the Venn diagram. We will go through that as well. And after understanding the basics of set, we have to understand some terms. Every chapter has certain technical terms, and similarly for today, in the chapter on sets, we shall be having certain technical terms which we will understand. This includes the different type of sets. Number one, the rules for set operation, and therefore we will go through some basic terms, concepts and rules which you need to understand. Then coming to the operation of the sets, there are two major operations, one which we call the union of two sets, say for example, two collection of numbers or two collection of anything which you can perceive when they are united. So say for example, a group of friends who love football and a group of friends who love cricket, for example. So it can be a union of two sets. That means a combination of these two groups. Now there can be some people who like both football as well as cricket. So that is basically what we shall be understanding and computing. Rules about union and intersection. Then very important part of this chapter is the concept of subset and power set, and the pictorial, the way in which we show the union and the intersection. So when there is a union of two sets, we like this, A union B, and if there is an intersection of two sets, then of course we use a different symbol, and that is A intersection B. So this is the union and the intersection. We will learn each of them, and thereafter we will go into Venn diagram, which is the last part of set theory, after which we shall move to the problems and its solution. So first and foremost, we go into what is set. Now we are following, for every chapter we try to follow the study material of the institute. And here again, we are first understanding what is an object, and from there we will understand what is set. Now, in the language of mathematics, everything, whether living or non-living, is called an object. So everything in this universe, it can be, say, for example, boxes, it can be, say, copies, it can be group of people, it can be buses, cars, trains, it can be planets. So everything within the boundary, of course, living people, say, for example, a group of people I was saying who have an interest in cricket, a group of people who have interest in hockey, a group of people who love both football and cricket, a group of people who like tea as well as coffee. So everything in this world is composed of objects. This is strictly from the mathematical language. Now, what is a well-defined collection of objects? So when it is possible to tell beyond doubt whether a given object is in the collection under consideration or not, then we call it a well-defined collection of objects. For example, a case of even number set. So if I say that we want to take a group, a set is basically collection. We say a set of pens, a set of, say, for example, files. Maybe I am having some office files in my hand, set of files, a set of instruments. So set is what? Set is a collection. Set means a group. Okay, so maybe I'm having some set of, say for example, markers. So I have a set of markers. So here 3 of them are black, 1 is blue. So a set of markers. So set means a group. Set means a number of articles, a number of objects. Now if I say that case of even number set, if I say that we are considering right now the group of all even numbers, and then if I ask you a simple question, I'm writing a big number on the board. Okay, I'm writing a big number. So first of all, we are assuming that we are taking the set of even number. That means set means a group. So I'm writing group of even number. You know what is even number and odd number. Okay, now even number, normally we write set like this, like curly brackets. So this even numbers, we have taken even numbers, case of even numbers. So you know that 2, 4, 6, 8, these are the even numbers. 1, 3, 5, 7, they become the odd numbers. So if I say that we are considering a set A, in very simple words, it's like a group, okay, or like you have a party with friends, a group of friends. It's a group of numbers. It's a say a well-known defined collection of numbers. And what if you want to be a member of this group? What should be your characteristic? Your characteristic should be that you should be even. That means the number should be even. Okay. So then if I ask you, I'm writing a big number randomly, which comes in my mind. Say 7, 9, 2, 4, 8, 4, 6, 7, 6, 5, 5, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. So it's a long number. But if I ask you whether this number, okay, is going to be a member of this particular set, what do you feel? Please see the number 7, 9, 2, 4, 8, 4, 7, 6, 5, 5, 4. Okay, let me add 1 to it. Why should? So let me also add 3 here. No problem. 1, 7, 9, 2, 4, 8, 3, 4, 7, 6, 5, 5, 4. It's a huge number. But the question is this number a member of this set? Answer is yes, because you know that every even number is divisible by 2. So I've already got Sakshi. Many of you have answered yes, because it's even. Very good. So you can see number of responses are coming. Sakshi, Shambhavi, Manisha, Sanyam, Mayur, Panchal, and we have Pitlat Wala Khojema from Western India region. So yes, why? So you are very intelligent in understanding this, because the last digit is 4. Please see, the last digit is 4. That means whatever long the number I write, if this number is divisible by 2, automatically it will be a member of this group. So friends, you can see this set which I was writing, or a group, is a well-defined collection of objects, because whatever number you take, just by looking at the number, you will be able to say whether the number will be a member of this group or not. Okay, so definitely you were 100% correct in saying that this number is going to be a member of this set A. Now I'm writing one more number, and you have to say whether the number is correct or not. Let me make some changes. Let me write a fresh number here. Okay, now I'm writing a number 7779955 6821. This is also a large number. 77799556821. I have written it randomly. Now it is a large number. Will this number, just looking at the number, can you say, is this number going to be a member of set A? So I think no. The moment, so this is an odd number, as you can see, it ends with 1, right? Kindly see the last digit. So the last digit, it ends with 1. Therefore, this is an odd number, ODD. This is an odd number. Since it is an odd number, so therefore it can never be a member of set A, because set A, as we have seen, is a group of even numbers. Okay, so this is the first concept. So what is set? Now, if you see page 7.2, we are going to the second sub module of this chapter, you will find that set is nothing but a collection of well-defined distinct objects. And we will see that the way we define this object, okay, it can be listed or it can be described. So each element will be known as an element, each object will be called an element of the set. So let me write a simple set and let us try to understand which are the elements. So I'm writing a set B and the set is A, E, I, O and U. So can we say that these there are 5 members of set B, and each of this set, that is A, E, I, O and U, these are the individual members, and each of them are known as what? They are known as elements. Okay, they are known as elements. So they are called elements. So you can say they are members of the set. They are all members of the set, and if you see the letters A, E, I, O, U, you can easily understand that these are the vowels in the English language. So we have taken the 5 vowels. In other words, set B is a set of the vowels in the English language. Okay, so we denote sets by capital letters. As I've done, you can see all sets will be written in capital letters, and you can see that the members of the set, we write the elements, that is each member means an element, so we write that in small letters. Okay, the last question, many of you got it correct. No, because it's an odd number. Okay, great. Many of you, Mohammed Ali, Sanyam, Deepika Rani, Harshika, Archana, Shambhavi, Bhumika, Arpita, Gautam, Monica, Neha, Namita, Jaspreet and Sanket. Thank you. Thanks for your feedback. Now we move on to further concept of set. So set is a collection of things. For example, if I say that you have so many books which you are studying for your foundation. So you have books on accounts, you have books on law, you have books on commercial knowledge, business and commercial knowledge, you have books on mathematics. And again, within mathematics paper, there are 3 subdivisions. So you are having study material for mathematics, for statistics, and also for logical reasoning. So you can say a set, you have a set of books. Okay, set is a collection of things. So I've given some examples here: hat, shirt, jacket, pants, the set of pens you have, the set of copies, everything. Set of cars, for example, say a millionaire or billionaire has a fleet of cars. A fleet of cars can be called a set or a collection of cars. So normally we write set like this, curly bracket, second we say the second bracket, and that's how we denote the members of each member of the set. And the members of the set, it's known as element. So please remember the term element. So each of them, A, E, I, O, U, in this example, are the elements of the set B. So I will always write the set name in block letters. Normally we use A, B, C, X, Y, Z like this. And the name of the members we usually denote with small letters. You can have a set of numbers as well, definitely. And for example, the set of whole numbers will start from 0, 1, 2, 3, and it will continue. Set of prime numbers, you can see the example 2, 3, 5, 7, 11, 13, so on. Okay, so definitely the set concept is very simple. Okay, now let us see the example. Okay, Sakshi has a question. Small letters is elements. We always write the elements in small letters. Okay, otherwise what will happen? It will become confusing. The name of the set, set A, set B, set C, set X, Y, Z, whatever you call it, that will be usually denoted in capital letters, block letters, and the elements, that is the members of the set, usually denoted with small letters. Of course, in case of numbers, there is nothing called capital or small letters, but when we take words or when we take, for example, letters, okay, we usually write it with small letters. Okay, there's one more question from Jatin Lalwani, the question is how many elements can be there in a set? So that we will see. So just hold on for a few minutes. We will understand that sets again can have finite, it can have infinite elements. Okay, but we will deal always with finite sets. Yes, set, Omisha Mishra has stated, set is a well-defined collection of objects. Yes, and you know object means anything in the universe, living or non-living. Okay. Namita, thank you for your, yeah, mathematics is much easier, and you will see that it is one of the most interesting topics as well as you go along. And always be relaxed, practice, it's very scientific, logical, and with your level of intelligence, I have full faith and respect in all your intelligence, your dynamism. Mathematics definitely will be an interesting paper and a scoring paper for you in the exam. Now let me take an example. Say you have made a set or a group of 10 friends. So I'm taking the names, you know, I'm writing small letters, A for Ankit, B for say Bibhash, C for Chunky, okay, whatever. So you can just call your name, call your friends, whatever names you give them. I'm just taking 10 names. Each friend is an element or a member of the set. That is absolutely clear. So each member, so you have formed a group of friends, and there are 10 elements there, 10 friends. So we always use lowercase, as you saw. And now we are taking an example. Say there are 3 friends, A, C, and D. Sorry, that's 4 friends, A, C, D, and H, who play soccer. Okay. So if they play soccer, we can create a further. So I will just write the sets now. First, I will write the set of all friends. Since friends start with the letter F, I am writing F. F is the set of all friends A till J. So A, B, C, D, E, F, G, H, I, and J. So we have set of 10 friends. They are all friends of yours, and 10 friends, each of them, please note, we have written in small letters to denote that they are the elements of the set, and the set is F. F stands for friend, your friends. Now, there are 4 friends, A, C, D, and H, who play soccer. Okay, who play soccer. Now, since they are playing soccer, okay, so we can say that we will form another set, right? So we will take another set and we will call it soccer, S. So we are taking A, C, D, and H. A, C, D, and H. Okay. Then we have, so we can say that the set of soccer is made up of the elements A, C, D, and H. There are 4 elements in the set S, and there are 10 elements in the set F. Now let us see that there is another group. C, D, and J also play tennis. C, D, and J also play tennis. So I can write a set of, I will use the letter T, T for tennis, and there are 3 members in the set. So it is C, D, and J. Please note that there are some common factors here. C and D not only play tennis, they are also playing soccer. Please note C and D are also here. Okay, so in this way we have created from the parent, from the main or the parent set F, we are creating smaller sets, set of friends who play soccer, set of friends who play tennis. And therefore, if I ask you, who are the guys, who are the friends who play both soccer and tennis? Both soccer and tennis. So already I was giving a hint. You can see the friends who play soccer, A, C, D, and H, and the friends who play tennis, C, D, and J. So if I ask you the set of people who play both soccer and tennis will be basically 2 friends, C and D. So this is called the intersection of the sets, because you can find from here the common factors which are there in both set S and set T. We have only 2 members who are playing soccer as well as tennis. Okay, so this is how we create sets and we write. Let me take some question. Okay, Some points are coming. Yes, set of papers. Yes, correct, Sakshi. Then favorite cricketer is not a defined set. Yes, there is one question from, there's one observation from Sufal Pramod. Yes, a very interesting observation. Favorite cricketer, if I ask you set of favorite cricketer, is it a defined set? He has raised a very interesting point. If I ask you your favorite Bollywood icons, okay, so you may think of including, say, Nawazuddin Siddiqui, Vicky Kaushal. Okay, you might think of the three Khans also because they have been ruling Bollywood for quite some time. You might think of Akshay Kumar, Ajay Devgan, for example. You might also think of the late Irfan Khan, the late Sushant Singh Rajput. They were also wonderful actors. Now, still, if I ask you set of favorite cricketers, set of favorite actors, it is not going to be well defined. Why? Because the perception will be different. One of you might think that, no, my favorite actor is Nawazuddin Siddiqui. Somebody might feel, no, he is not one of the top actors. I feel, say, for example, Ayushmann Khurrana is better. Okay, so therefore, you can see that favorite cricketers, set of favorite food. Now, favorite food, the choice of the best food for one person may not be the same as another person. So these are not well-defined set. Okay. So well-defined set means it should follow a rule. It should follow a particular principle. It must follow logic. For example, we took the case of even number and odd number. I wrote a long, very long even number, but everyone quickly responded and said, they gave the correct answer. They said, yes, this will be a member of the set. Why? Why could you do it? Because the rule is, I took the case of even number, and all of you know any even number should be divisible by 2. So this is well defined. Okay. Fine. Yes. Shiva, good that you have understood. Okay, now there's one question from Panchal. How is the sets useful in practical life? Well, yes, practical life sets are useful. You will see in real life, we always try to find out set of those people who are common. For example, if I say there could be set of people who are only BComs, there could be a set of BComs, I mean to say Bachelor of Commerce, they hold the degree of BCom. There could be a set of people who are chartered accountants. There could be a set of people who are both BCom and CA. Similarly, you could have a set of people who are chartered accountants. You could have a set of people who are MBAs. But there could be some people who are both CA and MBA. So in real life, set has its application, and even in our core areas, you will find later in finance and other areas, you definitely deal with sets. For example, set of shares, okay, set of stocks, stock market, right? All of you know, stock market, set of shares which are doing well, set of shares, that means group of those shares which are not doing well. Okay, you know the Bombay Stock Exchange Sensitive Index is composed of a set of shares. There's a collection of shares. I can ask you that what is the set of those companies which came out with an IPO last year? For example, Zomato, for example, Nykaa, for example, Paytm. So it is a group. So set can be used even in the world of finance, accounts, audit, and later on in audit also you will learn some applications of sets. Good. Okay. C and D, very good. Thank you, Shaizeen. Sakshi also, thank you. Set of people who are yes, there can be set of people who are illiterate. Yes. Set of literate people, set of illiterate people. Yes, definitely. So, Shaizeen, I hope you understand now that we are learning sets in foundation because it has practical applications. Okay. Now, let us see the set of these sets. First one, set A. You can easily make out A, E, I, O, U. So the set is written, if you see the slide, it is written in capital letters, and set A is composed of 5 elements, small a, small e, small I, small o, small u. So that means set A is nothing but the set of vowels. 2, 4, 6, 8, 10. So these are what? These are the even numbers which are below 10. So a set of even numbers which are below 10, or sorry, up to 10, okay, less than equal to 10. So you have 2, 4, 6, 8, 10. C, PQR, PRQ, QRP, RQP, QPR, RPQ. So what is this? This is a set of all possible permutations of the letters PQR. Okay. 1, 3, 5, 7, 9. What is this set? So we can say this is a set of all odd numbers which are below 10. So you have 1, 3, 5, 7, 9. 1 and 2. So this can also mean a set. For example, 1 and 2 can be the roots of an equation, of a quadratic equation, right? So there could be a number of sets. Now, friends, we go to the next point, that is how to write the sets, and there are simple points. Yes. Yes, Shambhavi. Yes. PQR, you got correct. Set of even numbers. Yes. Rohini. Komalakshi, thank you. Correct answer. Permutation. This is basically permutation of PQR. Okay. Not combination. We call it permutation. Combination, in combination, PQR and QRP will be the same, but in permutation, it will be different. Now, this is called roster form. The moment, like some people who have problem in the teeth, they wear braces. Okay. So similarly, when we write in this particular style, when we use this second bracket, it is called roster form, roster, or called braces. So when I say that set S is, say for example, if I say the set of 3 exams which you need to appear in CA. So it is, I write, say foundation, sorry, I'll write in small letters, say I write foundation, intermediate, and final, FINAL. Okay. Foundation, intermediate, and final. Set of 3 exams which you need to complete in CA, in the normal routine, in the normal course. So here again, we can see this is a roster form or a braces form. And there is another method which is called set builder form. And set builder form, the examples are like this: the set of vowels in the alphabet. So if I say that, can you write the set of vowels in the alphabet? So definitely you will find that the set of vowels in the alphabet will be A, E, I, O, U, A, E, I, O, U. And if you look at the A, E, I, O, U, the 5 vowels, well, you could write it in set builder form. Also, you could write in braces form. When I write in this way, it becomes braces. Okay, right. Yeah, set of all numbers. Yeah, Manisha, GP presentation is already there, uploaded in the site, I think, and I will also come up with some more questions and MCQs later on. Okay. Now, set of even numbers between 2 and 10, I took the example, set of roots of the equation x square minus 3x plus 2 equal to 0, when we took the example of 1 and 2. Now, set builder method. Set builder method, we just write like this. If I take the second example, what you see on the slide. Okay, let me take the first example first. Okay. X is equal to 2m and m being an integer lying in the interval where m is greater than 0 and less than 6. So what will be the answer to set B? How to write set B? So what you see here is the set builder method. So they are saying how to build the set builder, how to build the set, how to prepare the set, how to document, how to write the set. Okay, how to create the set, that is set builder. So here you see the relation is given, a logic is given. The logic says that x is equal to 2m. So I'm writing x is equal to 2m. Fine. What is the value of m? M is an integer, that means a whole number, okay, which lies in the interval 0 to 6. So m is greater than 0 and less than 6. So therefore, if I ask you, what are the possible values which m can take? M cannot be 0 because it is given m is greater than 0. So m can be 1, m can be 2, m can be 3, can be 4, can be 5. But can m take the value of 6? No. Why? Because it is given that m has to be less than 6. So when m is 1, the relation is, you see, the relation given is x equal to 2m. So when m is 1, x will be 2 into 1, that is 2. When m is 2, x will be 2 into 2, that is x will be 4. When m is 3, x will be 6. When m is 4, x will be 8. When m is 5, x will be 5 into 2, that is 10. So therefore, if I ask you, can you write the set? Yes, you can. I'm writing the set here for you. This is the braces form. Okay. And what we do is, it is called the roster form or the braces form. I will just take these numbers 2, 4, 6, 8, 10. So I write 2, 4, 6, 8, and 10. So this gives me set B. So this is how we convert a particular number or a particular set from the set builder process to the roster process, or from the set builder to the braces of the roster process. Okay. So this is set builder or algebraic, it's also known as algebraic rule. So it's based on algebraic relationships, right? Okay. So Omisha, I think you have understood the difference between roster form and set builder form. So when we are writing the roster form, it is just the name of the elements, but when we are using set builder, the relation, how we are getting this X, the logic, the relation is also included within the set. That is why it is called set builder. It shows you how to build the set, how to create the set. Okay. Now elements of a set can be everything, numbers, we have taken numbers, digits, people. I was talking about a set of people who are, say, commerce graduates, a set of people who are science graduates, a set of people who are chartered accountants, set of people who are MBAs. So you could have a set of people. A group of people, say for example, a group of people from India, a group of people from US, a group of people from Canada, from Germany. So there could be separate groups or sets. And now we come to equal sets. So we will look at some definitions and some basic concepts. This is again an easy chapter and not at all complicated in any way. So we can describe a set by defining a property, or we might list the elements in the set. When we list the elements in the set, basically we are writing, what are we doing? When we write the elements in the set, basically we are using, we are listing the elements. We are not defining the property, we are not defining the rule, we are not defining the logic. So that is called the roster or the braces method. And set builder method means when we define the property. For example, we wrote here that x is equal to 2m, and m can take any value more than 0 and less than 6. So that is where we are defining the property. So you know, from this relationship, from this property, you know what could be the possible values of x. Okay. Now please note that the order in which they are listed is not important. Very, very relevant point. Set comprised of, say if I write 1, 2, 3 and 1, 3, 2, they mean the same. So if I create two sets here, and if I say that the order of the elements, say I write set A is equal to some subjects I'm writing. So I'm writing accounts. Just a moment. Say I'm writing first, let me take law. Okay. I'll write law here. Okay. Law. Accounts. I'll take economics, and I'm taking maths. Okay. So this is set A. If I say that, if I write set B like this, if I write accounts first, and then I write maths, and then I write law, and then I write economics. Okay. So will this be same or different? So please note, in set theory, the order of listing is not important. The order of listing is not important. So A and B are equal sets because basically they both contain the same elements. Like, okay. So here we can say that law, accounts, economics, and maths. Here I've written accounts, maths, law, and economics. The order is different, but the same elements are there. Okay. So therefore, ideally they are actually the same set. Now we come to subset. Okay. So very simple concept. Let us take an example of subset to understand better. Okay. So we are writing two sets, and in most of the cases, we will use the braces or the roster form, right? Yes, both sets are same. Yes, correct, Harshika. Yes, both sets are same. Thank you, Shiba. You are understanding. Good. Okay. Now, please see this set which I am writing. I am writing the set. Let us say I am writing Q. Q. Okay, Q. Q is the set of numbers 1, 2, 4, 8, and 10. Okay. If I say P is another set and P contains 2, 4, and 10, please see the sets. Q contains 5 numbers 1, 2, 4, 8, and 10. P contains 3 numbers 2, 4, and 10. 3 digits, 3 numbers are there 2, 4, and 10. Please note that all what are the elements of P? How many elements do you see? There are 3 elements. If you look at P, you will find there are 3 elements. How many elements are there in Q? So in Q, we can see we are having 5 elements. So Q, please note, we have 5 elements 1, 2, 4, 8, and 10. And in case of P, we are having 3 elements 2, 4, and 10. Now, all the elements of set P, if you see carefully, all the elements of set P are also the elements of set Q. Please note that. So here we have 2, 4, and 10. Each of them I can map. 2 is here, 4 is here, 10 is here. So P, we can say P is a set which is composed of elements which are also there in Q. So P, we say, is a subset of Q. Very, very important. So we can write P is a here we can write P is composed of elements which are also elements of set Q. So in the set notation, we write P is a subset of Q. Okay. And that means it is like P is the bigger set here, smaller set here, Q is the larger set, right? So P is a subset of Q. And therefore, what happens? Q becomes the superset of P. So it's the opposite relation. P and Q, they have relations, and P is the subset of Q. Q becomes the superset of P, right? Thank you, Nimish and Man Singh Rai. Thank you for your comments, for your following the session. Similarly, there are a number of examples. So now if I say what is a proper subset, if P is a subset of Q, but P is not equal to Q, then P will be known as a proper subset of Q. Okay. So in the example you see in the slide, A and B, set containing the 2 letters A, B is definitely a subset of the set A, B, C. Okay. So that is called a subset. And if P is a subset of Q, but P is not equal to Q, then P will be called a proper subset. So here, please note, P contains 1, 2, 3 elements. Q contains 5 elements. Is P equal to Q? Can you say P is equal to Q? No. So here P is not equal to Q. So P is called a proper subset. A proper subset of Q. Now we come to some terms, very simple terms. Singleton set. Singleton set means it has only one element. Okay. So singleton, as you know, single means one. So if I write something like this, say for example, take a set A and say I write only one name of one fruit, apple. Okay. So I have written only one fruit. So it is a singleton set, right? So one element is a singleton set. Equal sets, very important. Now we come to the important understanding of equal set and equivalent set. Equal set and equivalent set. So what is equal set? Equal set means 2 sets will be equal when all the elements, every element of one set is there in the other set as well. So it's like a mirror, you can call it almost like a mirror image. So if I take an example here, so let us take set C. C C contains some elements. Let me write the elements. So it is 7, 5, 2, and 3. Okay. And we have another set D. I am taking the set in this way: 2, 5, 2, 5, 3, and 7. So we can see that all the elements in set C are there in set D also. 2, 2, 5, 5, 7, 7, 3, 3. So therefore set C is equal to set D because all the elements of set C are there in set D as well, each of the element. Right? So if you see the example here, 2, 4, 6. Set A is 2, 4, 6, set B is 2, 4, 6. Even if it is set B, if set B is 2, 6, 4, still we will say it is equal. Now, what is equivalent set? Achha, there is one concept called null set. Null set means empty set. There is nothing in null set. Okay. So this is just, we don't use null set much. This is just, you can say, a simple concept. Null set is known as phi. P-H-I. We pronounce it as phi. Okay, this is called null set. That means empty. Nothing is there in the set. Empty set. Nothing. That is called a null set. So it has no proper subset also. Now, equivalent set is what? Equivalent set means when the number of elements in one set is equal to the elements in the other set. So please note here, the numbers are not the same. The elements are not the same, but the number of elements is equal. So two finite sets A and B are said to be equivalent if the number of elements in one set is equal to the number of elements in another set. So let us take an example. So I'm taking a small example here and just write set A is having the numbers 1, 2, and 3. Set B has X, Y, and Z. Please see the sets. Set A has 3 elements, 1, 2, and 3, its numbers. Set B has 3 elements, X, Y, and Z. Set A has 1, 2, and 3. And set B has X, Y, and Z. Right? So, do they have the same elements? No. But if I ask you, what is the number of elements of set A? That is NA. 1, 2, 3. So I'll write 3. How many elements are there in set B? That means what is the number of elements of set B? 1, 2, 3. So both have the same number. So we can say A and B are equivalent. Please note I am writing equivalent, but I am not writing equal. It is not an equal set. It is an equivalent set because the number of elements in one set is equal to the number of elements in the other set. Okay, so it is equivalent set. Okay, null set. Sakshi, null set. It is called NUL, not a non-set. It's called null set, NULL. I'll just write once again. Null set means it has no element in it. Okay, so singleton set means one element. And if there are 0 elements, no element, we call it a null, N-U-L-L, null set, N-U-L-L, null. Null and void, we use this term in law. What he said is null and void. Null means ignored. Null means it is no longer going to stand. Null means 0. That means it has no effect. Null and void. So null set means a set which is having no elements. Okay, so we show it, we write with this Roman letter phi, and we show it as like this, empty set. This is an empty set or a null set, and this letter which you see here is pronounced as phi, P-H-I, phi. Right. Now we proceed to some examples. 1, 3, 5, 2, 4, 6. Are they equal sets? No. Are they equivalent sets? Yes, absolutely. Very good, Bhumika. You have given the right answer. A and B in the last example are equivalent sets because they have the same number of elements. Absolutely. Good. Okay. Sufal is asking, can null set be a subset of any other set? Very much. A null set can be a subset of any other set. Okay. Sarvesh has a very interesting question. Sir, can set be equal and equivalent at the same time? Okay, let me let me try and find out. I will write it. Okay. Sarvesh, thank you for asking this question. Okay, I will try and see. Sarvesh has a very interesting point. Can set be equal and equivalent at the same time? Okay, I'm writing. You can tell me. Please follow and tell me whether I am correct or not. I am taking two sets here, X and Y. So I am writing, X in capital, Y in capital, and I'm using the braces form or the, what do you call it, roster form, right? So I'm writing this set as, let me take three elements here. Okay, any three elements. Let me take, A, B, and C. Okay, A, B, and C. And I take set Y and I write C, A, and B. Are they equivalent? Answer is yes. Why? Because there are three elements, there are three elements. So they are equivalent. Okay, no doubt about it. Same elements. Are they equal also? Are they equal also? Just think. Yes, they are equal because they have the same elements. Here also you have ABC. Here also you have ABC. Of course, I wrote it as CAB, but then in the language of set, the order does not matter. That means whether if I say a family, father, mother, and son, okay, or a father, mother, daughter, son, okay. So if I write like this, a set of family, F, and if I write this father, mother, daughter, and son, FMDS, okay, I'll make it all small, FMDS. Let me just write it all in small letters. FMDS. So F, M, D, and S. So we have father, mother, daughter, and son. This is one family. Let us call it F1. And F2, I am writing son, daughter, mother, and father. Okay. So this is F2. The question is F1 and F2 are same? Are they same? Are they equal? First of all, there are 1, 2, 3, 4 elements in set F1. In F2 also, son, daughter, mother, father, 4 elements. And we have the same elements in both the sets. We have those elements. Of course, you can change the order. You can change the sequence. But ultimately, it is mother, father, daughter, son. So therefore, F1 will be equal to F2. So this is an example. And also X and Y, if you see, they are equivalent as well as they are equal sets. So please remember, if when two sets are equal, they have to be equivalent also. Please remember, two sets have to be equivalent if they are equal. So if they want to be equal, they must be equivalent. But every equivalent set does not mean that they are equal. Okay, this is very, very important. Okay, correct. Right, Shufal. I hope you have understood now. So here it's, but the elements of A are not in B. So here you can see set A and B, they are equivalent. Why? Because they have the same number of elements. Both have 3 elements each, but are they really equal? No, because they don't have the same numbers. The same numbers are not there. Okay, we proceed to the next point. So they are not equal, but they are equivalent. Universal set. Universal set is an example we have taken. So set universe, as you know, the collection of everything. So 0 to 9 we have taken. This is an universal set S. And I have taken a set P 0 to 468. 0 to 468. And I have taken another set Q, which is 1, 2, 3, 4, 5. And from there, I will try to find out P dash and Q dash. Okay. So this is a very important point, and requesting all of you to kindly pay attention and listen to this concept of universal set. So in the universal set, what happens is, let me take the set here, S equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it is a set of all integers below 10. Okay. Now I am taking a set P. P is 0, 2, 4, 6, 8. P is equal to 0, 2, 4, 6, 8. So if I ask you what is P dash, P dash means the universal set minus set P. So this will be basically set S, universal set S minus P. How do you find out S minus P? You have to find out all those elements. Please listen. You have to find out all those elements which are there in S but not there in P. So for example, here you can see, if you look at the elements here, you can see 0, 2, 4, 6, 8. So I will take those elements which are there in S but not there in P. So 0 is here, 2 is here, okay, 1 I will write, 3 is not there, 5 is not there, 6 is there, 8 is there, so 7 and 9. So this particular P dash, this is equal to set S minus P, 1, 3, 5, 7, 9. So you can call it a complementary set. Similarly, if you take Q, 1, 2, 3, 4, 5, you can find out Q dash. Just check the slide, you will understand. Okay. This is an important illustration. 3 is a proper subset of 2, 3, 5. Yes, 3 is a proper subset. It is a subset, but it's not equal to 2, 3, 5. So therefore, it's a proper subset. 1 and 2 is not a subset of 2, 3, 5. Why? Because in the set 1, 2, you have one particular, you have the digit 1, and 1 is not there in the set 2, 3, 5. Right. Yeah, two sets can be, yes, Manoj is writing, two sets. So let me see, two sets can be, Shiva is writing, yes, two sets can be equivalent and equal also. Absolutely possible. And basically, is all equal set equivalent? Yes, all equal set. Manav has asked this. All equal set is equivalent. Yes, all equal sets have to be equivalent. They need to have the same, exactly the same elements. So the number of elements will be the same. Okay. Okay. Now, Ishita Kubar has asked a question, an interesting question. Of course, whether 0 is a nice one. She has written this 0. So let me just draw the curly bracket, 1 and 2. So she has said, this particular set, if I have 0, will this be a null set or a singleton set? Well, 0 ultimately is a digit. It is a digit, so it cannot be a null set. It is a singleton set. Singleton set. So if you get a question like this, that A is equal to set which contains the digit 0. Is this a null set? So you will think, oh, 0 means nothing, so it will be a null set. No, it will be wrong. It will be wrong. So therefore, you have to understand that in that situation, what happens is, please understand that 0 is ultimately a digit. Okay, it cannot be equated with emptiness. A null set is empty, that means it has nothing. But 0, if you see, 0 is definitely a digit. For example, answering this question from Ishita, let me say 0 has a meaning. I can say that A, that is 0, is basically the set of the number you will get if you find out any number. Say you take any number, okay? If you take any number, and if I say that if you subtract the same number from itself, what will you get? You get 0. If I say, okay, say 78. So 78 minus 78 will give you 0. Similarly, 0 has a significance because it is considered as a number. So this particular set, and if I write B, which is nothing, which has nothing inside, okay, this is an empty set because there is no digit. So this is null set. So I can write B is a null set, 5. But A is a singleton set because it has one digit 0, and 0 itself we cannot neglect or ignore 0 because 0 is a number ultimately. Acha. Now we come to some calculations. A set containing n elements will always have 2 to the power n. Okay, it will have 2 to the power n subsets. Yes, Shazin, I will discuss subset again through many examples. De Morgan's law we will do later, Romisha. Don't worry on that now. We'll do it later, much later. Okay. Manisha is asking what is the standard time to solve a question. We will take these questions later on because that is not exactly in relation to the chapter we are covering. It all depends now. You know the number of questions you get, you know the time. Just divide the number of questions. Okay, the time which you get, just divide the time with the number of questions. So you know that, okay, how quickly am I supposed to solve, right? Per question, how much time I get. But the sooner you do it, the faster you do it, the better it is. But then please remember in CA, it is not only speed, but speed with accuracy. Acha. A set containing n element will always have 2 to the power n subsets. So this type of question comes in the exam if there are, say, for example, 5 elements in a set. Okay. If a set has 5 elements, how many subsets will it have? So it will always have, if a set A, say NA is 5, that means the number of elements is, say, 5. So how many subsets will it have? The number of subsets will be 2 to the power 5, 2 to the power n. And out of these 2 to the power 5 subsets, how many will be proper subsets? So it will be 2 to the power 5 minus 1. Okay, this will be the proper subset. So if a set contains 3 elements, that means it will have 2 to the power 3, that is 2 into 2 into 2, 8 minus 1, that is 7 proper subsets. Right. So I've given an example here, proper subsets of 1, 2, 3. So what are the proper subsets? You will have a set 1, 2, 1, 3, 2, 3, 1, 2, 3, and the null set. Please note the null set is included. So you have 1, 2, 3, 4, 5, 6, 7, and 8. This is proper subsets. So we have 7. Okay. Now, important note is empty set has no elements, as you saw. I took the question, I think, from Ishita, whether the set containing 0, is it a null set or a singleton set? The answer was it is a singleton set. And universal set is set that has everything, all the elements. Okay. Complementary set, everything that is not. So what's one example of complementary set? Once again, I took an example a little while back. One more example of complementary set. So set A contains A, E, I, O, U. Set B has E and I. So if I ask you what is B complement, how to find out B complement? Very simple. B complement will be, first let me open a set. So I will create a set. I will just create the braces form, and I will find out what is B dash. B dash is equal to basically A minus B is B dash. That means all those elements which are in A but not in B. So what are those elements? So E and I are common. E and I are common. So A is not in B, so I'm writing A. O is not in B, I'm writing O, and U is not in B. So B dash becomes A, O, and U. So this is a complement. So this is called B complement or B dash. Dash, we are putting a dash. It's actually known as B complement. Okay. This is also easy. Elements of a set may be listed in any order. Please, if you get a question in the exam, please remember the elements of the set can be set in any order. So A, B, C, if a set has the 3 elements A, B, C, and another set has the elements B, A, C, both are same, both are equal, and of course equivalent. Now we come to the cardinal number. Very, very simple. We have already done it. The number of distinct elements in a finite set is called cardinal number. Okay. So therefore, when we are discussing set, So what is the cardinal number of set A? So the cardinal number of set A, NA, is 5, because A, E, I, O, U, there are 5 elements. Number of elements in the set A is 5. So the cardinal number is 5. Okay. Yeah, 32 subsets. Many of you have done it. AOU, yes, thank you. Not possible to call out the names continuously, but I am following. Rohini, for example, has written Sangeeta Chaudhary, Shambhavir, Priyanka, fine. Vanshika, good, good. Okay. So cardinal number is easy. Power set also we have discussed, the collection of all possible subsets of a given set is called the power set. So if you are getting 1, 2, 3, then power set will be 1, 2, 3, all possible combination 1, 2, 1, 3, 2, 3. Okay. Please note we have taken 1, 2, but we have not taken 2, 1, because 1, 2 and 2, 1 are the same. 1, 3 and 3, 1 we have not taken. 1, 3 and 3, 1 are the same, so we have not taken, because the order does not matter. 2, 3, 3, 2, we have not taken 3, 2. Okay. We have taken 1, 2, 3, 1, 2, 1, 3, 2, 3, and individually set 1, set 2, set 3, and the null set. The null set is the square symbol which you see at the end. Okay. So this is okay. This I think you have understood, null set. Now let us see the set notations. Yes, very simple notations. You might get some questions on set with some notations. So you can see the notations. If I write, I will take a complete example now. Okay, we will learn all these symbols in one example. So I am taking a set P, or let me take a set U, universal set. Let me call it the universal set. And I am taking the set, say it is 1, 2, 3, 4, 5, 6, and 7. Fine. This is a universal set we are taking. Set A is 1, 3, and 4. Set B is 1, 3, 5, 6, and 7. Please see the sets. Okay. And I'm taking another set here, that is set C, and the set C is 6, 7, 8, 9. Okay, please check. Right? Now, please see carefully, and I request you to write. Right? It's a standard request I have every day. Please keep your pen and paper ready. I know you are doing it. Just a small reminder, because we have completed 1 hour afternoon session. So you may be feeling little dizzy or little sleepy, but then you are becoming chartered accountants in the next few years. So always have that extra dose of energy. Achha, now let us try this one. Yeah, Shazin, yeah, almost everything in this chapter is linked. You don't have to learn lot of concepts. There are no formula. Only one formula, I would say. Only one formula. And that we will see. A intersection B. Okay, so other than that, A intersection B, A union B, the link between them, there's only one formula which you need to remember. And of course, Venn diagrams will do, but otherwise it is easy. And since you are understanding this part, Venn diagram will be simple to understand. Okay. So here you see A is 1, 3, and 4. Now, if I ask you, is A a subset of U? So let me go step by step. Is A a subset of U? Answer is what? 1, 3, 4. It is there in the elements. There are 3 elements in set A, 1, 3, and 4. In U also we have 1, 3, and 4. So I can say A is a subset of U. This is number 1. B has 1, 3, 5, 6, and 7. And U has 1, 2, 3, 4, 5, 6, and 7. So all the elements of set B, that is 1, 3, 5, 6, and 7 are also there. 1, 3, 5, 6, and 7. Please see. So I can write the second relation number 2. B is also a subset of U. B is also a subset of U. But a small question to all of you. can you also say that C is a subset of U? Can I say C is a subset of U? Just check. Can I also say that? Okay, very good. Many of you are answering. Sonali, Deepika, Vidya, Nimesh, Jaspreet, Sangeeta, very good. So yes, we can say that I think you have understood A and B both are subsets of U. But C, please see this particular set C. C has 6, 7, 8, 9. 6 and 7 are here, but 8 and 9 are not there. 8 and 9 are not there in U. So C is not, I show a cross sign, C is not a subset of U. How do we write it? We write in this way, C, you can see C is not a subset of U. Set C is not a subset of U. Subset sign is this one. Subset sign is this one. But not a subset means we do this. C is not a subset of U. So this is the first relation. Now, quickly we go to union intersection from the same example. So I will just rub this part. I'll just create some space so that we can do the union and the intersection part. Now I request you to work with me and find out A union B. So A we have 1, 3 and 4. B we have 1, 3, 5, 6, 7. What is union? Union means just get the members of each group together. That's it. Just get the members of each set together. And union means united. Okay, integration. So let us do it. A union B will be 1 comes, 3 is there, 3 comes here, 4, okay, 4 I take, 5 I will take, 6 I will take, 7. So 1, 3, 4, 1, 3, 5, 6, 7. So the union becomes 1, 3, 4, 5, 6, 7. Please do it with me. 1, 3, 4. Yeah, thank you. Many of you have written C. Yeah, 2 is not there. Okay, you have written correctly that in case of set C, C is not a subset of U because we have 8 and 9. Very good. 8 also is not there in U. We have 1, 2, 3, 4, 5, 6, 7. Okay, now A union B is done. I hope you are clear with this. Now if I ask you A intersection B, A intersection B, A intersection B, it is inverted U. Intersection we write like inverted U. A intersection B will be what? Intersection means common points. Okay, common points. So say for example, a person who's doing CA is studying economics. So you are studying mathematics, economics, accounts, and logical, of course you're studying logical reasoning, computer, you're studying BCK, business and commercial knowledge. Now, say another person who's doing engineering is studying mathematics. Apart from that, he or she is studying mechanical engineering, computers, artificial intelligence, and all that stuff. So you are doing CA foundation, you are studying many subjects. You have a set of subjects you are studying, but one of the subjects is mathematics. The other person who's doing engineering is studying a different type of papers, but there also out of those papers, he's studying mathematics. So therefore, I can say that the common point between you and that person is mathematics. Mathematics is where you are intersecting each other. You are basically overlapping each other. Correct? Understood? Clear? So this is the concept of intersection. So intersection means the common points, the common elements. So let me find out A intersection B. So what are the common elements in A and B? Let me find out. 1, I'm circling with blue. 1 and 1 common. 3 is also common. 3 and 3 common. But 4 is not there in B. Similarly, 5, 6 and 7 are there in B but not there in A. So therefore, I'm getting only 2 letters, only 2 elements. And therefore, I will write A intersection B is nothing but 1 and 3. Okay, so I think you are clear with this. We took a very simple example and we are able to find out A intersection B 1 and 3. Bhumika, not, no, 1, 3, 4 is not right, Bhumika. Please check. 1, 3, 4. No, because 4 is here, but 4 is not here. Please see. In B, we have, in set B, we have 1, 3, 5, 6, and 7. So only 1 and 3 are common. Kindly note, only 1 and 3 are there in set A as well as in set B. Therefore, A intersection B will be 1 and 3. Okay. Others have got it right. So, yeah, Bhumika has got it right again. Priyanka, Monica, Deepika, Mansi. Yes. Very good. Yes, Manav, very good. CA and engineering, yes. Common point is mathematics. Absolutely. Great, great, great. Very good. Okay, so union means signifying coming together, and we have done union now. So it is basically A or B, basically. Intersection means the common elements, right? Intersection of two sets means common elements. Complement, we have already seen that it is basically those elements which are not there in the set. So you're given a set X. There are certain elements. You are also given the universal set. So those elements which are there in the universal set but not there in X will be X complement. Okay. So I will now go to Venn diagram. This is what you see here is basically Venn diagram, also known as Euler's diagram. So very simple concept, and this is one of the easiest chapters you have in your syllabus. So we are going to understand union. So I'm taking two sets here. Two sets I'm drawing, A and B. A has, let me take 1, 3, 5, 7, and B has 2, 7, 6, and 8. Okay, I'll add one more here, 9 also. So set A has 1, 3, 5, 7, 9. Set A has 1, 3, 5, 7, and 9. This is set A. Set B, what do you get? Set B is equal to 2, 6, 7, 8, and 9. 2, 6, 7, 8, and 9. 2, 6, 7, 8, and 9. So if I ask you, if you intersect, what are you getting? If you intersect, you are getting the intersection point, shows 7 and 9. So A intersection B is very simple. You get 7 and 9. Because these two, 7 and 9, are there both in set A as well as in set B. It is there in set A, okay, as well as in set B. So it is the common factor, and therefore it is included in A intersection B. What is A union B? So if I write A union B, very simple, I will just get all those elements together. Very simple job. So I will take 1, 3, 5, 1, 3, 5, 7 and 9, 7 and 9, and I will also take 2, 6 and 8. 2, 6 and 8. Fine. The work is over. So that is union and intersection, as simple as that. So union of two sets, we have seen A union B. Take the example in this slide. Kindly check the example in this slide. Yes, 7 and 9. Many of you got it correct. Thank you. Okay, Varun is asking the question, what is A minus B? A minus B. Okay. Chalo, we will take a small example. This is, I think, clear. This is a Venn diagram, what we are doing. Okay. So let me take A minus B. Varun, I think your name is Varun. Yeah, Varun Malay. I'll take this example. I'm taking set A and set B. B is, say, for example, chalo, A is 10, 20, 30, 40. And let me take B as 10 and 20. So A minus B, you just subtract B from A. So what do you get? 10, 20, if you leave aside, you get 30 and 40. Those elements which are there in A, which is not there in B. So A minus B, you can write as B complement, and that is nothing but 30 and 40. A minus B is done. Please see in this slide, 2, 3, 6, 10, and 15, set A. 3, 6, 15, 18, 21, 24 is set B. And you have set C, 2, 5, and 7. A union B is just check if it is correct or not. 2, 3, 6, 10, 15, 18, 21, 24. What will be A intersection B here? Just try to find out the common points. Also try to do A union C. So you have 2, 3, 6, 10, 15 will always be there, plus you have 5 and 7, 2 additional points, 2 additional elements. And if I ask you from here, A is given, B is given, and if I ask you what will be A intersection B, that is not done in this slide. So we will do it. Okay, we will do it. So A you can see from the slide, B also you can see from the slide. So let us find out A intersection B and A intersection C. I have done the union here in the slide. Intersection we will do now. So first is A intersection B. A intersection B, what will be the answer? So A you can see 2, 3, 6, 10, 15. B is 3, 6, 15, 18, 21, 24. Which elements are common? Please find out. 3 is common, 6 is common, 15 is also common, I guess. So you can see there are 3 elements, 3, 6, and 15, which are there both in A and B. Okay. So this is done, and now we go to A intersection C. That means the common elements in both A and C. If you look at set A and set C, I think you will get only one letter which is common, one number which is common in both set A and C, and that is 2. So we get, this is the answer of A intersection B and A intersection C. So let me see, some of you might have done it. Yes. Last example, 30 and 40, absolutely. Sakshi, Priyanka, Shiba, thank you. Very good. Okay. So we have done A intersection B and A intersection C as well. Right. Now we speed up. Union we have seen already. A union B, and intersection you can see the shaded area. It is shown by inverted U, and you can see that intersection means the joining or the integration, and when you talk about union is basically joining, and the intersection here means that you are trying to find out the common elements in the 2 sets. So we could do this problem. Intersection we have done 3, 6, and 15 in this slide, and A intersection B is 3, 6, and 15. A intersection C is only 2. Great. B intersection C. Okay, the last one is left. B intersection C. I'll go back once again. B is given here. Do you see any common element? 3, 6, 15, 18, 21, 24. That is set B, and set C is 2, 5, and 7. Is there any common element? No, there are no common elements. Therefore, B intersection C will be a empty set, or you can call it a null set. A intersection C is 2, which means a singleton set because it has only one element, right? And B intersection C will be a null set. Good. Yeah. Yes, who has Bhumika has given the correct answer. I mean, a revised answer. A intersection B is 3, 6, 15. A intersection C is 2. Excellent, excellent, superb. Okay. Please see this small example. 1, 2, 3, 4. Set A is 1, 2, 3, 4. Set B is 3, 4, 5, 6. You could get questions like this. A intersection B is very simple, the common ones. So 3 and 4. It is shown by the red portion. Okay, and you can see there are 2 sets A and B. The red portion shows the common area 3 and 4. Please see this example. Union and intersection. Set A is 3, 4, 5, 7. Set B is 2, 4, 5, 8. Please note A intersection B. Specifically, I request you to note A intersection B. A intersection B is basically those elements which are there both in A and in B. So you can find out it is basically 4 and 5. Right. Let us do this one. 1, 4, 5, 9, 13. B is 2, 5, 6, 8, 9. We have to find out intersection and union. So let's put our pen and paper together and let us try it out quickly. Okay. So A is given 1, 4, 5, 9, 13. I'm just writing it directly in the Whiteboard. On the whiteboard, A union B and A intersection B. Okay, A union B. I will take all the numbers which are there. Of course, I will not repeat any number because the idea is union means or, either in A or in B, right? So I will take A union B. Just 1, 4, 5, 9, 13. So I will take 1, 4, 5, 9, 13, and I will take the elements from set B. So I will take 2, 6, 8, 2, 6, 8, 2, 6, 8. The others are there because you can see 9 is common and 5 is common. A intersection B, we can easily understand out of the 2 sets given. Please work with me. You will find 5 is common, 5 is there in both the sets, 9 is also there. So A intersection B is 5 and 9. Okay. Yes. Please check it and just ensure it's correct. Right. Now we go into Venn diagrams. We were doing this. This is called Euler's diagram. Euler has been a very prominent mathematician. And Euler has gifted us a lot of theories and theorems which are there in advanced mathematics, higher mathematics. So Venn diagram was basically, for the first time, it was introduced by Euler. So it's also known as Euler's diagram or Venn diagram. Euler and Venn jointly they did it. Okay. So in the relation, this is the first and the only formula which you need to remember, and that is A union B formula. So please note A union B is always equal to A plus B minus A intersection B. This is basically what we are talking about. So if I show it through a Venn diagram, what happens? If I draw this, a Venn diagram, this is set A, this is set B, A and B. This whole is the universal set U. So A union B will be the full A which you see here, full A plus the full B, plus the full B. Just follow as I shade. But please note this part I have shaded twice. So A plus B is done, but this part I have shaded twice. Once when I was coloring A, I shaded it once, and when I colored B, set B, I shaded it again. So the common part has been counted 2 times. This is not correct. So you have to delete once. So I will subtract A intersection B. That means this portion, which I am now darkening, this portion was counted twice. So I am now separating, I am reducing, I am decreasing it by 1. So A plus B minus A intersection B. Okay, so that gives you the formula for N A union B. Great. Yeah, this is a Varun. Yes, absolutely. You can, many of you gave the right answer to the last one, 5 and 9. Mohammed Ahmed, Chandan Patro, Manav, Bhumika, Archana, Gopalakrishnan, T.S. Gopalakrishnan, Shiba, Mohak, Panchal, Sakshi, Omisha, Shiba. Very well done. Well done. Excellent. Varun has given an observation. Sir, we can remember all formulas by visualizing Venn diagram. Absolutely correct. Just visualize. Mathematics is all about fun. Mathematics is all about drawing. You remember the last problem we were doing, that bouncing of the ball in the GP problem. If you visualize that the ball is bouncing and going up to 4/5 of the height, and just picturizing, visualizing. So visualizing Venn diagram means you can easily solve all problems in set theory. Of course, this chapter is not at all difficult, you can see, and only one formula to remember. Okay, now the last version of the formula is, you can see here, when there are 3 sets, what happens? Okay, so this was 2 sets. Now, if I have 3 sets, then it becomes P, Q, and R. P, Q, and R. So when you have to find out the union, so first, please note, just follow as I do the shading. First, union. So union means getting everyone together, right? So family union, reunion of your friends. Okay, so it's all getting together, getting all of them on the same page. Okay, getting them in one group. So first I shade P. I'm shading P. Okay, P is shaded. P is done. So I'm writing P with a separate color here, black. P is shaded. Now I have to shade Q. I will be shading Q. Okay, I'm shading Q now. Please see I'm using a horizontal line now. Okay. Please note this portion has been shaded twice. Now I'm shading R, but before that I will write the fact that I have shaded Q. So I will write Q here plus R because I'm going to shade R now. R I am doing like say circles. Okay, circle, circle, circle everywhere. I'm just writing. I'm drawing circles. Circle. So if you see carefully what has happened, again, these portions, this part has been counted twice, this part has been counted twice, this part has been counted twice. So what we do is we take P plus Q plus R minus P intersection Q minus P intersection R and minus Q intersection R. Then this common point which you see, which I am darkening now, this portion is there in P also, this portion is there in Q also, this portion is there in R also. This is added back. So what we do is P plus Q plus R minus P intersection Q minus Q intersection R minus P intersection R plus P intersection Q intersection R. Okay, you just have to remember this formula. Of course, very few sums might come on this formula where there are three sets involved. Okay. Yeah, set is an easy chapter, Amisha, as you have written. Yes. Okay. This is the only you can say the only formula which you need to remember. Now, when PQR are disjoint, very easy, extremely easy. Then what happens? PQR will be equal to P plus Q plus R. What do you mean by disjoint? This is conjoint. Okay, this is conjoint. This is called conjoint. Okay, this is conjoint. Why? Because they are joint. They have common points. They are joint. Right? You think of the Olympic logo, for example. Right? They are conjoint circles. Conjoint. You think of the Olympic logo. So you have one circle, two circles, three circles, 4 and 5. So they're conjoint circles. But if you have disjoint circles means they are not joint at all. P is here, Q is here, R is here. Very easy. In that case, there is no question of any intersection. So P union Q union R will be simply equal to P plus Q plus R. As simple as that. No question of any treatment for the common shaded area. There is no shading at all. This we cannot be shaded because they are absolutely not overlapping. So they are all disjoint. So this is called disjoint. Disjoint. Okay, disjoint. Now the last one is product set, Cartesian product. If there are two sets A and B, say for example A is 1, 2, 3 and B is 4 and 5, what we do is very simple. What to do? 1, 2, 3, 4, 5. We have to find the Cartesian product. Cartesian product means we had a chapter earlier in mathematics which is no longer there in the curriculum, that is matrices. In matrices we used to do something like this. Okay. Now Cartesian product of two sets A and B. So A is given 1, 2 and 3 and you have set B which is 4 and 5. You have to find the Cartesian product. Okay, so A into B. A into B will be nothing but take the pairs together. So I will take 1, 4, comma. Then I will take 1, 5, okay. Then I will take 2, 4 and 2, 5, okay. So 1, 4 and 1, 5 is over. Then I will start with 2, 4. Just think of the pairs, 2, 4 and 2, 5, and then I will take 3, 4 and 3, 5. So 3, 4 and 3, 5. It's a big one. A into B is a big one. So I have taken 1, 4, 1, 5, 1, 4, 1, 5, complete. 2, 4, 2, 5, complete. 3, 4, 3, 5. Okay, this is called Cartesian product. So we are taking one simple example. So if A and B is given 3, 2, 3, 4, 5, 2, 5, 4, you can easily understand it's a product form. So basically the two sets are 3, 5 and 2, 4, right? Because we can see that 3, 2, 3, 4, 5, 2, 5, 4. Okay, so it just means, once again, I'll just solve it. The product is given 3, 2, 3, 4, 5, 2 and 5, 4. 5, 2 and 5, 4. So it is easily understandable if A into B is this. So A will be what and B will be what. So we can easily understand the first digit is 3 and 5. So this has to be A. And the second digit is 2, 4, 2, 4. So B will be 2 and 4. As simple as that. Okay, it's absolutely crystal clear. So this is how we break a Cartesian product into the individual sets. Okay, now we go to the last part and we'll take some questions here. Very interesting question. It has been taken from the study material out of a group of 20 teachers. Okay, please try to understand this problem. Okay, out of a group of 20 teachers, what will be the way to handle this question? Let us see, out of a group of 20 teachers in a school, whether the data which is given shows you 10 teach mathematics, 9 teach physics and 7 teach chemistry. 4 are teaching mathematics and physics, but none teach both mathematics and chemistry. So let us solve this problem. It's a very easy problem, won't take much time. Just I will draw the Venn diagram and explain. Okay, and you can follow it in the whiteboard as well as you can see the slide. So here we are taking 3 subjects, P, C and M. Okay, so since it is P, C and M, so we are taking 3 sets here. We take P, set M for mathematics and set C for chemistry, PCM. So we are taking, this is physics, P. So 10 are teaching mathematics, fine. But there could be some people who are teaching mathematics as well as other subjects, maybe chemistry or physics. Now they have said 9 teachers are there who are teaching, 9 teach physics and 7 teach chemistry. 4 teach mathematics and physics. So I can write 4 teach mathematics and physics. So mathematics teachers who are teaching both physics and chemistry is X. So physics is P, this one, chemistry is this one, physics and chemistry, let us call it X. So this portion is X. This portion is X. This portion is X, fine. Now the question, it is given that no one teaches mathematics and chemistry. So mathematics and chemistry, they are no one. That means this part is also empty and this part is also empty. There is 0, no one, I am writing 0. Mathematics and chemistry, no one, no one. Please note this, please understand this one. Okay, so you can easily understand that if this is physics, chemistry and mathematics, okay, and X teachers are there who are teaching both physics and chemistry, and it is given that 4 teachers are teaching mathematics and physics. Physics and mathematics, we have 4. So I can say that if this total is 10 and this part is 4, this part is 4. So this portion, the white portion, is 10 minus 4, that is 6. Now we will add up. Now let us see, this part is 4 and this part is x. This is 0. This is 0. This circle. Okay. So you can see this is 7 minus x. So since it is 7 minus x, please note how we are solving it. Okay. So what we are doing now? So now the total has to be equal to 20. So now the total is equal to 20. So we are going to add up all of them and equate it with 20. The question is how many teach only physics and how many teach chemistry and physics. So we have to find out this x, right? So what we do is, please note what we do here is, once again I am explaining that you can see that here we have got physics, chemistry and mathematics, physics, chemistry and mathematics, okay, and the total number of teachers is given 20 teachers in the school, 20 teachers in the school, okay, and from here we can see that 4 teachers are there who are teaching. There are 4 teachers are there who are teaching both physics and mathematics. Okay, so it is given. 4 teachers are there who are teaching both of them. Now comes the question. So the total number is 9 minus x minus 4, 9 minus x minus 4, and here 7 minus x. Please see, I am explaining once again. Total 20 teachers in the school, 10 teaches mathematics. So I have taken 10 teachers mathematics, 10 teachers mathematics. 4 are teaching mathematics and physics. So this common part is 4. So the remaining is 10 minus 4, that is 6. This portion, the white portion, is 10 minus 4, that is 6. Because this part is 4. So the white portion, that means those people who teach only mathematics and not physics, will be 6. Okay, so that we have got. Number 2. 9 minus x minus 4. Why? Because total number of physics teachers is 9. The total number of physics teachers is 9. It is given 9. This part is x. The common portion is x. Right? 9 minus x. And this part is 4. So it is 9 minus x minus 4. 9 minus x minus 4. Now we equate all of them. Once we equate all of them, what do we get? Six here. So I'm writing plus 6. Plus 7 minus x. Plus 7 minus x. And here we have 4. Okay. Plus 4 plus x. Plus 4 plus x. This gives us 20. This gives us 20. Okay. So therefore, if you see, once we add up all this white portion, I will use the blue pen now. Okay. So 9 minus 4 minus 6 is this part. This is this part. This white portion. That means it is basically those people who teach physics, but they don't teach chemistry and mathematics. Right? So that is 9 minus x minus 4. 6 is this part. This portion is 6. You can see 6. So 6 we have got. 9 minus x minus 4 we have got. 7 minus x is this part. That means the white part. That means those teachers who teach chemistry, but they don't teach other subjects. And finally, we have the common area 4 and x. So 4 plus x, that gives you 20. So from here, if you solve for x, x comes to 2, which is correct. Some of you have got it 2. Acha, 7 minus x, Sakshi is asking 7 minus x how? 7 minus x how? Please note, once again, let me go back to the problem. Sakshi, please listen carefully. So it is given that how many people are there who are teaching physics and chemistry? Just check. So it is given that how many are teaching? Just let me check the problem once again. None teaching chemistry, acha, physics and chemistry. 10 teach mathematics, 9 teach physics, and 7 teach chemistry. So the total number, 7 are there who are teaching chemistry. So I've taken 7. But out of them, we want to find out how many are there who teach both physics and chemistry, and we have taken it as x. So therefore, 7 minus x, this white portion, if I shade like this white portion is 7 minus x, this portion is 7 minus x. That means those people who teach chemistry but do not teach physics or mathematics. That is how we are getting 7 minus x. So if you solve for x, you are getting 2. So that means the answer is 2 teachers teach both physics and chemistry. And when it comes to the question on how many teachers teach only physics means 9 minus 8. Seven, 74% are Indians. 74% of the Indians are like grapes. Okay, so I think you are clear with this question, the way we have solved it. 74% of the Indians like grapes. 68% like bananas. What percentage like both grapes and bananas? So this is a direct question. Let P and Q. Okay, so we know that it is a percentage. It is given percentage. So the total percent has to be 100%. Okay, the total has to be. I am writing P bananas is equal to what percent? We have 74. So basically, I'm just creating NP or NB as 74. NB is 74. And 74% like grapes. So I'll take grapes, G. I'm taking G. And N banana is equal to 68. Okay. So therefore, we have to find out how many are there who like both grapes and bananas. That means N of B and G, those people who like both bananas and grapes. Both bananas and grapes. Okay. Please note 74, 68 and 100. So this will be shown like this. Number of people, the percentage of people who like grapes. So I will take it as 74 plus 68 minus 100. So once you have this, you will get the answer will be, if you just calculate it, it comes to 42% because we are using the formula Yes, sir. Yes, yes. Today there is some problem going on actually. Our entire complex is suffering, basically problem. Okay, okay. We are continuing now. Now you are. I am audible now. Okay, okay. So now we can see here that yeah, we can see 74 plus 68 minus 100. So that gives us 42% of the Indians who are liking both grapes and bananas. Okay. Now we go to the next question. In a class of 60 students, this is also very similar to the last one which we did. So it is very similar to the last one on physics, chemistry, and mathematics. Let me take example 4. In a group of students, 65 play football, 45 play hockey, and 42% play cricket. 20 play football and hockey. 25 players are playing both football and cricket. So there are three. You can see there are three groups. So there are three types of sports: football, cricket, and hockey. So here it is a direct application of the formula which we use, and that is P intersection EP union Q in union R. So when there are three sets separately, how to find out the union? So we know the formula, we have used the formula, we just put the value F, H, and C, we create the three sets. Step 2 is to get the information which is given. Number of people playing football is 65. Okay, number of people playing football is 65. Number of people playing hockey is 45, and number of playing cricket is 42. So we just find out the intersection. F intersection H, that is football and hockey, is 20. Football and cricket is 25. Hockey and cricket is 15. From there, we also have seen that number of people who play all the three sports, football, hockey, and cricket, is 8. So therefore, step 3 is the total number. We just add up all these individual parts and we subtract the intersection parts. So we get total is 100. Okay, so if you just work it out, you will get the answer is coming to 100. 65 plus 45 plus 42 minus 20 minus 25 minus 15 plus 8. So F, football, hockey, cricket, and then we subtract all the intersections part. Okay. Now we go to the last part and we check some of the questions here. Which of the following two sets are equal? Okay. Which of the following two sets are equal? Please see the, now we are focusing back to the presentation. Please check the presentation. Which two sets are equal? So here we can see option 1 is A equal to 1, 2 and B 1. That is not an equal set. If you see the last answer, option number D is the right one. 1, 2, 3 and 1, 2, 3. Okay. So option number D, if you see, is the right one, where you have two sets. Set A is 1, 2, 3 and set B is also 1, 2, 3. This is the first example. Second example is dash is an ordered collection of objects. Now, what is an ordered collection of objects? Definitely it is set. Set, as we have discussed, set is an ordered collection of objects. So therefore, set is an ordered collection of objects. Mr. Himil, am I visible? Okay. PPT is not visible. Will I share it once again, or I'm just sharing once again? Okay, just a moment. I will just share once again. Okay. I will just go to the slide. Just let me know if the slide is visible. Oh. Okay, I'll come to the slide. Yes. Okay, we are here actually. Okay, we are now it is visible now. Oh. Okay. So we are doing this question. Which of the following two sets are equal? set A is 1, 2 and B is 1. So that is not correct. You can see second option is also not correct. The last option is correct because it has two sets 1, 2, 3 and 1, 2, 3. Set A is also 1, 2, 3. Set B is also 1, 2, 3. So the last option is correct. Last option. Option D is correct. Second question, a dash is an ordered collection of objects. So it is, the answer is set. A set is an ordered collection of objects. So option number C is correct. So it has to be set. Next, question number 3. The set of odd positive integers less than 10. So if it is odd, it is given it is positive integer, but it is odd. So it has to be 1, 3, 5, 7, and 9. So it is odd positive integers. So it has to be the second set, second option, 1, 3, 5, 7, and 9. 1, 3, 5, 7, and 9. Okay. So here option number C is option number B is correct. 1, 3, 5, 7, and 9. Many of you have got it correct. Okay. Okay. Determine the total number of sets, subsets of the following set. Please note, we have discussed, I'm just using the whiteboard once again. Now, you can see that there are some digits, some letters given, H, I, J, K, L, M, N. So we have 3, 4, 5, 6, 7 elements in the set. So how many subsets can be created? How many subsets? We know the formula is 2 to the power n. So here it will be 2 to the power 7 because there are 7 elements. So it will be 2 to the power 7. Okay, correct. Last question. Yes, many of you have got it right. Okay, 1, 3, 5, 7, and 9. Perfect. Now, if you see, this will be 2 to the power 7 because there are 7 elements. So 2 to the power 7 will give us how much? 2 to the power cube is 8. So 2 to the power 6 is 64. So 2 to the power 7 is 64 into 2, that is 128. Answer is 128. Question number 4, the answer is 128. Option A is correct. The next question, the number of subsets of the set 2, 3, 5 is how much? So this is exercise 7A, and the number of subsets of the set 2, 3, 5 is how much? So it will be, is it 3, is it 8, is it 6, or none of these? The number of subsets of the set 2, 3, 5. In 2, 3, 5, we have 3 elements. So the formula will be 2 cube, 2 to the power n. Here n is 3. So 2 cube is 8. So correct answer is 8. It will be 8. 8 is the right answer. Next one, n into n plus 1. This is number 19. N into n plus 1 divided by 2, where n is a positive integer. Okay, is it a finite set? Is it an infinite set? Is it an empty set? Definitely it is not an empty set. It is it can be either finite or non-finite, infinite, but then it is given here that n into n plus 1 by 2, where n is a positive integer. So it will be basically a finite set, countably finite set. Okay, countably finite. Okay, now we are going to 21. This is very important. A union A is equal to what? So let us try this question. A union A is equal to what? Now, A union A, if I take A, set A, and if I unite A with A, so this is A. So A union A means what? I am adding A with itself. So it will be A only. It will be A only. Answer is the option A. Second one is A intersection A is equal to what? So A intersection A. So here again, if I write A here, and A intersection A means the common part of A. So it will be A. Answer is A. Okay. So 21 and 22 we have done. Now we are going to number 7C, exercise 7C number 9. A has 32 elements, B has 42 elements, A union B has 62 elements. How many elements are there in A intersection B? So we are trying to do this. Yes, A union A is A. Shiva, correct. A intersection A is also A. Many of you have got it. Right, Sania, Mohammad Ahmad, Dipanshi, Jaspreet, correct. Okay. Number 9 we are doing. A has 32 elements. Okay. So I will write the question. I'm writing NA. Number NA is 32. NB is 42. NB is equal to 42. And NA union B is 62. We have to find A intersection B. So we can easily understand A intersection B is equal to A union B minus A minus B. So this is equal to 32 plus 42. So first, this will be A plus B minus, because we know the formula A plus B minus AB. That is A intersection B. This is equal to A union B. So we have to find intersection. So we have to find this one. So the formula is A plus B minus A union B. A plus B minus A union B. A is how much? A is 32. So I'm taking 32 plus B. B is 42 minus A union B is 62. So we are getting the answer. 42 and 72 is how much? 42 and 32 is 74 minus 62. That is 12 should be the answer. A intersection B is 12. Next question, 7C, exercise 7C, number 11. There are number of subsets of the set 6, 8 and 11. So 6, 8 and 11, kindly note 6, 8 and 11. There are 3 elements. And we know that the formula is 2 to the power n. So we know that the formula is 2 to the power n. So if there are 3 elements, it has to be 2 to the power 3. 2 to the power 3. 2 to the power 3 means 8. So the answer is 8 elements. 8 subsets. Okay. Last one we are taking is number 10, exercise 7C, number 10. There are 20 children. 8 are drinking tea but not coffee, and 13 like tea. The number of children drinking coffee but not tea is how much? So this is a very interesting problem, and a similar problem already we have done little while back. So we are trying to solve this problem now. We are trying to solve this problem. Yes, many of you have got the last answer, 8. Yes, Bhumika, Harshika, Manav, Shiba, Sanyam, Jaspreet. Yes, then we have Janalakshmi, Shambhavi, Sarvesh, many of you. Very good. Let us take this one. There are 20 children, 8 are drinking tea. Okay, so we have to draw a Venn diagram. So we are trying to draw a Venn diagram. Options are given. Let us try and draw the Venn diagram. Okay. First is in a group of 20 children. So tea and coffee. So I am drawing 2 sets and there is an intersection. This is tea and this is coffee. Set T means those people who drink tea, and set C is those people who drink coffee. Now please note it is given total is 20 children. 8 are drinking tea but not coffee. That means what? 8 are drinking tea but not coffee. That means these 8 people are here. They are not in this part. They are not part of the intersection. They are this part. Okay, I'm just draw this. I'm shading it. They are this portion of the set T. They are not here. 8 people drink tea but not coffee. And 13 like tea. 13 people are there who like tea. Okay, there are 13 people who are liking tea. 13 people who like tea means what? 13 people are there who drink tea, who like tea, but there are 8 people who drink only tea. Please note, 13 people like tea. That means they have tea along with coffee maybe, but 8 people only drink tea. So this common part which you see, this part is nothing but 13 minus 8, that is 5. Okay, if this is 5, so let us see. So tea and not coffee is 8. We have taken that. So coffee likers, only coffee. If you see, the question is the number of children drinking coffee but not tea. So total we know is 20. Total we know is 20. This portion, please see, this portion is 8 and this intersection part is 5. Okay, so total, the shaded part which you see is 13. That means the white portion means what? 20 minus 13, that is 7. So the answer should come to 7 if you just reason, and this is one of the toughest problem in this chapter. So first, if you see, I think many of you have got it. 10B is, yeah, it is 7. Option number 2 is the right answer. So please see here, we took 8 people. 8 people are drinking tea but not coffee. So only tea. So we have taken the tea portion. And there are 5 people. We could easily find out 13 people are drinking tea or liking tea, and out of them 8 people only have tea. They don't have coffee. That means out of 13 people, 8 only drink tea. So 13 minus 8, that is 5 people are there who drink both tea and coffee. So we got this common part. This common part is 5. This portion is 8. This common part is 5. So the white part which you see here has to be 20 minus 8 minus 5. So it is 7. Okay, so this is an interesting question. And the last question, please note, is a town has a population of 50,000. Out of them, 28,000 read newspaper X. So we are just trying to solve this question, and then we will wind up. So total population is 50,000, 20,000 read newspaper X. So X we have 28. I'm taking in in short. I'm taking 28 as 20,000. I'm writing as 28 for ease of calculation, and 23,000 read Y, and 4,000 read both papers. So X intersection Y is 4. The number of persons not reading X and Y, both. Okay, so this is interesting question. A town has a total population. Total population is 50. Out of this, there are people who read X 28, Y 23, and X intersection Y is 4. So how many people are there who do not read the newspaper X and Y? So first here we have to find out X union Y. Okay. So here we have 28, 23, and 4. So let us find out X union Y. So it will be, X union Y. X union Y is equal to X plus Y minus X intersection Y. So X is 28. I am taking 28 plus Y 23 minus X intersection Y, that is 4. So I'm getting 28 and 23. That brings me to 51 minus 4. That is 51 minus 4. That is 47. I'm getting 47. Therefore, how many people do not read any newspaper? Total is 50. Total population is 50. And I'm getting 47 here. Therefore, the total number of people who do not read either X or Y is 50 minus 47. That is 3. That is 3,000. In this case, it is 3,000. So option number B is the correct option. Okay, so here you can see basically total population is 50,000. We have got 47,000, that is 47 here. Means what? It means people who read either X newspaper or Y newspaper. And out of those people, there are some people who read both X and Y. Okay, so therefore the answer is 3,000. Yes, many of you have got 3,000. Shambhavi, Manav, Sanyam, Samir, Priyanka. Good. Okay. Okay, so with that, we wind up today's session. That was the last problem we have done. And in the next session, we shall be handling the last topic, which I'll be taking up with you in this month, and that is on the relations and functions. So set theory we have completed. We have discussed about the different types of sets. Set is a well-defined collection of objects. We discussed about it. Set can be composed of any type of object. Anything in the universe can be considered to be an object. Number 3 is that we discussed about the type of set, the relation between set, subset, power set. Similarly, if a set has number of elements, and if the element of one set is equal to the number of elements of another set, then it is called equivalent set. And when the members of one set is exactly equal to the members of the other set, that means they are the same. In that case only we call it equal set. Therefore, all equal sets have to be equivalent, but all equivalent sets need not be equal. After that, we have discussed about what is union of sets, intersection of sets. We also discussed about what is null set, called was shown by phi. Singleton set we had discussed, and then we saw the important formula for union, that is A union B is equal to A plus B minus A intersection B, right? And thereafter we have taken the important problems in the exercises, and we have covered several problems. So with that, we are ending the session today on sets, and I will be uploading some questions later on in the portal. Please go through those questions, and some MCQs will be uploaded. And in the next day, we shall meet on 22nd to discuss about the chapter on relations and functions. So with that, thanks for your cooperation and your participation. See you on 22nd. Bye.